All right, everybody, welcome to lesson 1.3.b. This is the second part of us learning about formulas and equations and functions. What we're going to be looking at here is a way to have Excel or Google Sheets or whatever spreadsheet technology you're using change its answers based on like a certain piece of information or a rule that we're going to set up. We're going to learn four different things today. We're going to learn if statements, we're going to learn and statements, we're going to learn or statements, and we're going to learn not statements. And each of these has a specific type of use within the whole logic aspect of things. When I talk about logic, it's about getting our programs or our applications or our spreadsheets to behave in a specific way based on the data that we feed into it. It's kind of like we're training or building a very, very limited in power artificial intelligence that can tell us things based on the information that's going on. Because, if we look at these 5 exam grades, let's say that I got, I know I passed, I know I failed, I know I failed, I know I passed, and I know I passed. Just by looking at them, our brain can quickly crank them out. However, what if we had 500 rows of data that needed to be graded and figured out if we pass or fail? All of a sudden, we're starting to fall into this situation where this isn't going to be an easy task. But luckily, we can have our computer system take care of all of that for us. So what we need to do to set up an if statement, just like any other equation, right? We're going to start with equals if, and then parentheses. Inside of it, we can put 2 or potentially 3 things into this list. All right? So what I can do is first talk about what are my criteria. What is my necessary piece of information that I want spreadsheets to react to? What I need for it is I want to look at cell A5, which is a 75 on here. If I click on it, it'll show up, or I can just type it. I'm going to click because I'm lazy. If A5, now in order to pass a test, you have to have greater than or equal to 65. So in math classes, we would put in greater than equal sign. That means greater than or equal. If I just wanted it to be greater than, I would just drop the equal sign. And that looks a little more familiar to things that we've seen. If I want both of them, like I want 65 to be included because, hey, if you get a 65, you did pass the test. Greater than, equal to, and then I'm going to put in a number, 65. Then what I need to do is throw in a comma. Kind of like when a comma adds extra stuff to a sentence, a comma adds extra stuff to our function. Comma, what do I want to appear in the cell? What I'm going to put in is pass, like as in you passed the exam. I close my parentheses, and then I press enter. All right, and I got 75, gave us pass. That is the result that we put in. If I double click, I could even make it a little bit more personal. You passed, right? And then I press enter, and now it says you passed. Okay. Like we've learned with our functions before, we can also just go to this little blue square down at the bottom, right? And we can click to extend it. Say go further, go further, go further, go further. And now it includes everything on it. It includes basically the idea or the formula is carried on to the next row, the next row, the next row, and the next row. And they do talk about each of the new cells. For example, this one right here talks about A5 being greater than 65. But if I look down here, this talks about A9. So when we extend or drag that box down, spreadsheets are actually able to logically figure out what we need. Now, seeing false, I don't like seeing false. I want it to be a custom message on what I say. So what we're going to do is I'm going to include all these. Now I'm going to extend it this time to the right. I'm going to click that little box and drag it over. It should copy everything. Nope, it looks like it goofed up, so we're not going to do that. I'm going to Control Z to undo that. I am going to double click into here, and I'm going to just copy this whole formula. Right click, copy it, so I want the whole thing, and then I'm going to go into here and paste it. All right, let's just press enter to make sure it works. It does, it looks like it, so I'm going to drag this down, To extend that logic again, we have the exact same thing. But I want these falses to turn into a custom response. So what I'm going to do is I'm not going to edit each of these. That's just a waste of time. So I'm going to get rid of those 4 again. We're just going to make sure that this formula works first. Then we can do that click and drag thing down to extend it to make sure that everything's working well. We're still talking about A5, 75, you passed. If I double click into it, after the phrase you passed, before that parentheses ends, I can put in another comma, and I can say, hold on, I got one more thing to tell you, Spreadsheets. This one is when the if statement doesn't work. So if A5 is greater than or equal to 65, we're going to get the message you passed. Otherwise, at the end, you failed. And then I'm going to end. I'm going to add that period to the end of it just to make it seem a little bit more serious as well. All right, I'm going to press enter to lock in my formula. And it still says you passed. Well, but that's because we got a 75. I'm going to go in and change this guy. And let's make it a 25, just for this example. When I press enter, this was the original piece that we had, but now our improved formula says you failed. All right, that's pretty neat. So let's extend this logic now. We'll drag all the way down, 1, 2, 3, 4. And when I let go of it, all of the you passed and you failed custom responses that I wanted show up. And we can test it by changing any of these if we'd like. So we'll make this a 66. I press enter. We still get the you passed carried over to it. All right. So this is the first piece of, just using if statements to make them run and work within spreadsheets. All right. These if statements can do anything that we want. I can make this a dog, and I can go into here and say equals if parentheses E2 or E5 equals dog, comma, I can say woof, just like a dog would say, and then a comma, not woof. And I close my parentheses and press enter, and, well, dog says woof. If I have a cat here next, and I want to extend this formula and go down again, click it, drag it down, well, the cat is not woof because the cell E6, which is right here, it wasn't dog, so woof doesn't activate. So instead, I have not woof activating. All right. So if statements are a little tricky, it's something that we can all kind of grasp and gain the idea of. A little bit of it is about practice. A little bit of it is about just trying things around and just seeing if you can get the results that you want. Part of working with spreadsheets is how well can you work with solving problems and trying things and, running little experiments and things like that. If statements seem to be pretty well received by people when I teach them it, I think it's the second option that tends to confuse people just a little bit. All right. So that's the first piece of if statements. We're going to move on to next as and statements, where we can require 2 separate things. Let me just pause, grab a sip of water, and then we'll jump right into this again. All right, so now we're ready to move on to the and statements. What we have on here is how we can force 2 things to be calculated at the same time. And we're even going to go a little bit further, and we're going to include if statements with and statements. And it's going to get a little complicated and a little tricky, but we're going to figure it out just by repeating and trying things over and over again and seeing what works. So what we have here is, let's say we have a New York State Regents class. There's 2 main requirements for passing the class. There's technically 3 with passing the Regents, but we're going to say that you have to have a passing grade and you have to have your labs complete. All right, so we can just look at this. For example, 75 and complete, this person passed. 45 and not complete, they didn't do any of it. They didn't do the passing requirement. They also didn't do the lab requirement, so it's double not passing. Now we have the other examples. We have somebody who scored a 78, so they got the grade that's required, but they didn't complete their labs, so we have to tell them, no, you fail. And also, we have a grade of 62, They didn't pass the course grade-wise, even though they did complete their labs, but we still have to tell them that they failed the course. All right, so we're going to use two arguments or two ideas. And you could even go further and go wild and make 3 or 4 or 50 requirements. You can make as many as you want as long as it's useful. Making 50 and statements isn't going to, really like give us anything useful unless it's a very, very specific use opportunity. So let's look at this first one because this one looks pretty straightforward. This person did pass. So we're going to look at our AND results. We're going to make some results to appear for this individual. So I double click in. All right, what I'm going to say is equals and, so we're going to say it has to have both of these items completed in parentheses, right? I'm going to put this first thing, A23, so I can click on it to put it in or I can type it. All right, that has to be greater than or equal to 65, but I'm not done yet, comma, I have another requirement, B23 has to equal complete. And then I close the parentheses on it. And when I press enter, I get true. All right, because remember, computers tend to think of things as like true and false. We can actually change what it says over here, and we're going to look at two different ways to do it. We're going to look at the sloppy way to do it, and then we're going to look at like this compound, complex way to make it happen. All right, so this first one, 75 and complete gives us true, all right, because we have the requirements that A23 is greater than equal to 65. Well, that's true because it's a 75. That's a larger number. And then B23 has to have the value of complete. Well, it does, so we got true. Okay, so what I'm going to do now is going to use that little blue magic box at the bottom again, and I'm going to click it and drag, 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 and we get true, false, false, false. And I think those are the results that we had before, so I think we're good, right? They didn't pass, they didn't complete labs, no way they're passing the course. They did get a good grade, but they didn't complete their labs, they're not passing. They didn't pass grade-wise, even though they completed their labs, again, they're not passing. So we have true, false, 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 all right? Now what we can also do on here is we can make a complicated statement. The first thing I want to do, though, is show you kind of like the easy workaround, and if this works for you, then go for it. You just got to remember your system that you use. What I can say is equals if, oops, I wasn't clicked on here, equals parentheses, if parentheses, C23 equals true, comma, right? We have to put what the consequence or the thing that will happen is. I'm going to say pass course, end the quotes, and end the parentheses. Let's see what happens. Okay, we got a false, which is kind of weird. Because this is giving us some weird true logic and false logic, I got to remove the quotes from here. Now when we try it, we should get pass course. Okay, and what's interesting is we can 1, 2, 3, 4 it, and we got those falses again. What happened? Well, I know what happened. We didn't include a second item at the end of it. So comma, fail course. Now when I run it, I get pass course. Let's extend it to make sure it works. 1, 2, 3. Fail course, fail course, fail course. So that's pretty neat. That's one way that we can do it. We can go into this and say if C23 has the value of true, look at this as no quotes because remember this true is a result of Excel basically, giving us a value. That's what the and does. It says at the end of it, true, up here at the top. All right. Now, let's go back a step. Remove that, and let's even remove that. We're going to look at the idea of making compound things. All right, and that's going to focus on these two instead of these results that we've calculated. It's kind of like on here we had our first step, and then we had to move on to our second step. What we have instead, though, is I want to do both of these things while also giving us custom responses. I want to take the two steps and snap them into a single dual-stepped equation. All right, so what we need to do for this is we are going to make some things complicated. And this is something that you like play around with for a while, and then you see what you get as a result. So this is kind of like a sophisticated answer on doing it. It's going to say equals, if is going to be our first item, because it's kind of like with everything else. You do the inside operations with PEMDAS. You do the inner things first, and then you expand outwards each time, and you're allowed to look at different types of results. All right. So if parentheses, then I'm going to say and begin parentheses. All right. I want to say A23 greater than or equal to 65, comma, B23 equals complete, close the parentheses for and. So if this whole and system is correct, comma, pass course. Then I'm going to put another comma, fail course. And then when I press enter, oh, I need to close my parentheses. If I didn't do that, that would have been a problem. Press enter, we got pass course. So I think this worked out pretty well. Let's drag, 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 and boom, we still got the pass course and fail course happening. So again, let's kind of review this because this is quite a bit of stuff. So we say if it is the case that these two things combined with and are correct, we're going to say pass course. And if that doesn't work, we're going to say fail course. This takes a little bit of time to figure out and get familiar with. This is not something that you're expected to become a professional at immediately. This is something where I even looked at this the first time and said, that's too much. That's too much for me right now to, work with. So what you can do is instead go back to that first method where you can look at the true and false values of here and then do that. You just have an extra column, and honestly, who cares? Look how far Excel will go. I can keep going, 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 and I could probably go even further once I fill in this data. So like if I put in a letter there, I would hope I can go further on it. That's about as far as it'll let me go right now. I probably have to unlock it. But scrolling downward, I just got down to 1,000. We can add 1,000 more rows at the bottom if we want to add even more space. Computing power is pretty easy to come by right now. So we can play around with the stuff and we can make it as complex as we want. We just kind of have to have an idea of where we put each item and how we're referencing it. So and statements are hopefully pretty fair in terms of us, figuring things out and, just making sure that things work out if we just take our time with it. All right. So those are the and statements. Remember, the and statement requires both things to happen in order for you to be able to, get a true or a true out of it. If one of them is wrong or both of them are wrong, we get the falses. And translating to what we need in the context of this course, it's passing or failing. All right. The next thing we're going to look at is or statements, where we say, you know what? I don't require both of these. I just require one of these items to be true or to happen in order for me to say, yep, we're okay to go. And we'll take a look at that next. All right, so we are on to the next piece. What we're going to look at for this example of or statements is with seeing R-rated movies. There's a rule where you have to be 17 years or older, or if a parent brings you, then you can go see the movie. So the idea of this is, if you have both of those required, like if you're 25 and your parent's with you, like you can go see the movie. Let's look at some of these examples and see like what happens with or statements. Or statements are less picky. If we look back at our passing the Regents exams, you have to do both. If you don't do both of them, you don't get what you want. You don't get the passing status. So what we have on here, though, we're using or statements, which means that only one of these things must be true in order for us to be like okay for it. All right, so you must be with a parent or 17 years or older. So we can start writing these ideas and see exactly what happens. What we have here is with parent and their age. So the first thing just indicates if they're with their parent or not. We know that if you're with your parent, you automatically get the pass, like you're good to go. But if your age is a problem, the only way that can be an issue is if your parent didn't come with you. So let's look at that, all right? Let's see, this first one. Are either you have to be with your parent or 17 plus. They're with their parent, so we already know this is good. But they're also 17 plus, so this should be a yes. Okay? Let's look at this one. With the parent, they're not with their parent. Okay, but remember, we still have that age rule put into place. They're 14, so no, they're probably not going to be able to see that movie because there's no parent and they're not old enough. You have to satisfy one of those two conditions in order for it to work. Okay, let's keep looking. We have a 16-year-old who's with their parent. Because their parent's with them, their age doesn't really matter because, hey, like, you're with your parent, you're good to go. And then finally, we have a situation where the person is not with their parent, but they are 17. So they'll be good to go. So it's yes. Yes, you can see the movie. You may not see the movie. You may see the movie. You may see the movie. And so we're going to use that as an example with our OR logic to try to get those proper results. All right, so what we're going to do is just like with the AND, we're going to have equals or parentheses. Now we have to put in each of our requirements separated by commas. So the first thing we need to do is make sure the cell A39 equals yes. Ooh, pardon me for that. All right, so anyway, we have or A39 equals yes. We have one other thing that we will allow, comma, B39 is greater than or equal to 17. We can close our parentheses and we can press enter. And we get true, which means true means like you're going to see the movies. Okay? Using that logic, I think I can just continue. And now we have true, false, true, true. I believe we had allowed, not allowed, allowed, and allowed. So we're doing pretty well. Looks like we got those exact results that we wanted, right? Because we only required one of those scenarios or situations to be acceptable in order to let the person in to see the movie. All right, so just like before, we're going to do that simple version of kind of giving us text that we can use. We'll use it with if eventually at the end, but for now I just want to kind of give it a custom response. So or, remember the easiest way to do this would be equals if parentheses C39 equals true. Remember no quotes because this is a spreadsheet generated value. All right, comma, what are we going to say? Welcome. And then comma, if they're not allowed, not allowed. Real original, I know. And we can close that parentheses. So now if C39 has the value of true, we're going to say welcome. If that doesn't happen, we're going to put in not allowed. So then I'm going to press enter. All right, we got welcome. That makes sense. I'm going to click drag, drag, drag. Welcome, not allowed, welcome, welcome. Oh, cool, it matches up with these. So that was kind of our intention, and we got it to work out nicely. I'm going to do it again in the advanced version. So now what we're going to have inside of here is it's going to be a little tricky, but it's something that we're going to piece together. It's going to be equals. Sorry, I clicked on another screen for my reference sheet. Let's go from here. I'm going to say equals if parentheses or parentheses. We are going to say B39 equals yes, comma. We have another thing that we will accept. We'll accept either of these. Click here. B39 greater than equal to 17. All right, we're going to close the parentheses for the OR statement. And look at that. It even like highlighted like, hey, this parentheses matches to this parentheses. All right, now we still have that if statement we need to work on. So we're going to say, again, welcome as the positive or the good result, and then comma, not allowed. End our quotes, end our parentheses, and we press enter. We still got welcome again, and we also got 1, 2, 3 extended, welcome, not allowed, welcome, welcome. I think we got it. Cool. So or statements, remember, they're not picky. And we can even go a little bit further with this. So let's say, I'm going to say, let's say dog, cat, giraffe. And what we can say here is equals or parentheses, A45 equals dog, comma, B45 equals dog, comma, C45 equals dog. So we can actually put 3 or 4 or 50 or 100 requirements in here, and we got true. Now the only way this would change is if this turned into a zebra, and then we get false. But let's say I go to this one, and I change this giraffe to a dog, we're back to true. And if I change all 3 of them to dog, we're on like super true, because all 3 of them were satisfied in that matter. All right? So we can do 3 or 4 or 50 or 1,000, however many we want, as as far as you're willing to extend it, really. But I'd say anything after like 4 or 5 of them ends up becoming kind of silly, unless there's like a specific reason for you to analyze all of them. But again, this is just introductory, so you learn how these statements and this logic works. All right, so that is basically what the or statements are about. We have one last piece to touch base on, which is going to be the not statements. Basically, opposite day. And if you can kind of keep that mentality as we talk about it, you'll be just fine. All right, so we'll jump into that in a second. Again, I'm going to grab some water and take a little break from this because my throat has been hurting from talking so much. All right, so this is our last one for 1.3. What this basically comes down to is the not operator. The not is all about like opposite day stuff. So I'm going to use something really easy with like traffic lights. We have the red light at the top, and then we have the yellow light, and then we have the green light. I could go on a whole side tangent about it being actually called an orange light because it's closer to a pumpkin than it is to the sun or a lemon, but this is not the time nor place for that argument. But anyway, at the light, you're supposed to stop when you get to it. Yellow sign, you're supposed to slow down, and the green, you're supposed to go. But the way most people treat these stoplights are yellow and green. As long as you have the time to pass through the traffic and do everything, those are go, right? So another way to look at this is to say, when it's not red, you go. So let's try to do that. Let's just try to get information, where true means go. So true equals go, false equals stop, right? Those are going to be our rules that we're going to use. And I'm just going to color these differently so we can just kind of separate them. But this is our data we care about, right? This is our key or our rules or, any of that kind of stuff. So when it's not red, we want it to be, we want to be able to say, go. All right, so what we're going to do is we're going to say equals, you guessed it, not, parentheses, A54 equals red. All right, and then I close the parentheses, and when I press enter, I got false, right? Because it's false that it's not red. It's kind of like saying not, right? It isn't not red, because it is red. All right, and if I extend this logic, 1, 2, I should get true and true. These come out true because yellow isn't red, green isn't red. I could even put in cat, and we could even get an example that cat isn't red. So, as long as it's the word red, when I press that and change it, it automatically switches to false. So not is kind of interesting to use in case you say, oh, well, I got to check for this and this and this and this and this and all these different things. But if they type this one answer in, the whole thing fails. You could just look for not instead of trying to look for all of those specific items. All right, so with this, I would like to change the logic on this. I'm going to show you one more time on that with if statements. So it's going to be equals if, I goofed it up. Equals if parentheses. There we go. I forgot the parentheses. I click on this cell B54 equals, false is also something that I can type in, comma, I'm going to say to stop, comma, and go, right? So if B54 is false, so it's not red, we have to, it's not red, there we go. I'm going to stop, otherwise I'm going to go. If I press enter, I got stop, and right, red light says that we have to stop. If I click and drag this down, 1, 2, these both say to go. Now that's kind of confusing, right? And this is why sometimes putting those if statements based on another statement can get you into like this double, triple, quadruple, quintuple logic, and you're like, oh, my head's going to explode because this is so complicated. Let's make life easier. Let's get rid of that. We can delete that, and we can delete that as well. We're going to use the if statements on here, and it's going to make things a little bit easier to understand, I hope. So we're going to go into here, we're going to say equals if, parentheses, not parentheses. We're going to check to see if A54 equals red. Well, if it's not red, right, we're going to say go. We're not going to say stop, right? Because if it's not red, that means that we have the okay to drive through, and we're going to do that. If that doesn't work, if it's not red, we're going to say stop. Close our parentheses and press enter, and we got stop on the red light. That's good. And 1, 2, these should both say go, because these are not red, therefore we must go. None of the assignments or tasks in this tutorial are going to be too wild or insane. This, again, is something that you want to build up slowly but surely. You know, this is not something that you want to overstress yourself, make it overcomplicated. We just know how to grab opposite day data. We know how to grab or data, so either of those two situations work. We know how to grab and data when we can require two specific things to happen. And we also have the idea of if statements, where we can have our code behave based on certain rules that we create. That's all we're going to go into on this. You just need to know that these exist and know how to use them at a very basic level. Once you get that running, you can do a lot of cool stuff with this. So that's basically the idea of 1.3. Part of these, well, just the formulas and equations on logic. We still have to look at a couple more items as well. We're going to be looking at statistical data next, which like finding the average, the mean, the mode, the minimum, maximum, a lot of different stuff like that, and rounding. It's pretty helpful, actually. And then we can look at text, and then we're also going to look at making custom formulas as well, where we can actually plug in all the rules and details within our equation, and we can have it do all the math for us. So anyway, that's 1.3.b, logic functions. We got them done. We just got to move on to the next piece, and we got 2 more after that, and then we are set for, just understanding the base idea of functions and formulas. So moving forward, hopefully everything goes nice and smooth.